Chapter 8, Locus, Part 2. In Part 1, I have already introduced how to describe the locus. You should remember there are 7 types of basic example of locus. And then if I give you some of the constraints, you need to know what's the shape of the locus. In this part, I want to emphasize how to use algebraic method to describe the locus. Because sometimes if you do not know the exact shape of the locus, maybe we need to use the mathematical way to find the equation of locus and to see what's the shape of the locus. For example, example 9.8, I also want to demonstrate 2 methods to find the equation of locus P. With the question first, A and B are 2 points in the Cartesian coordinate plane. A moving point P maintains an equal distance from A and B. If you remember, if a moving point P maintains an equal distance from 2 fixed points, that is, the perpendicular bisector of line segment AB, this is the shape of the locus. That means the locus of P is a straight line which is perpendicular to AB and pass through the midpoint of AB. Then, because I know this is perpendicular bisector, and by observing the coordinate of A and B, can you see the y coordinate of A and B are equal? So method 1, I can find the locus. The equation of locus is this straight line. What's the equation of this straight line? This is a vertical line because the y coordinate of AB are equal. So this is a vertical line and pass through the midpoint of AB. So the coordinate of midpoint of AB is equal to, the x coordinate of midpoint is equal to x point 2.5. So you can write down the answer directly. X is equal to 2.5 because this equation is equal to x is equal to 2.5. This is first method. Remember, what's the difference between first method and the method I will mention later? Because you remember the shape of the locus, so maybe you can find the midpoint and you can find the slope so that you can find the equation of locus. But in general, I will use method 2 to find the equation of locus because sometimes you do not know the exact shape of the locus. So what can we do? Set up the relationship between x and y and these 2 points, set up an equation by using the given information. PA is equal to PB. So I know square root of x minus 0 squared plus y minus 3 squared. Because this is equal to PA is equal to PB. Is equal to square root of, by using the distance formula, expand it, take square on both sides and expand it. This is x squared plus y squared plus minus 6y plus 9. How about right hand side, x squared minus 10x plus 25 plus y squared minus 6y plus 9. And then you can cross out these 3 terms. And x squared also remain 10x is negative 10x plus 25 is equal to 0. Add 10x on both sides, so 10x is equal to 25. X is equal to 2.5. This is the equation of locus of P by using the given informations. Setting up the equation, simplify it, you can find the equation of locus. They are same, but what's the difference between method 1 and method 2? Method 1 is that you remember the shape of the locus must be perpendicular bisector. So you can find the answer by finding the equation of this straight line. But this example is quite easy because this is horizontal. So this the equation of locus must be a vertical line. X is equal to 25. Method 2, by using the given informations. Let's see example 9.9. Same idea. I know A is a point on y-axis. It's a fixed point, 0 and 12. A moving point P maintain an equal distance from point A and x-axis. That means P is a point maintain an equal distance between one point and one straight line, x-axis. What's the shape of the locus? If you remember, the shape is parabola. How can we find the equation? By using the relationship, the given information. I know PA is equal to the distance from this point to x-axis. So, what's the length of this part? Because the x-coordinate of Q, that means the foot of the point P to x-axis must be x0. So the distance between these two points, xy and x0, must be y minus 0. So this is y. And then the distance between P and A, you can use distance formula. So setting up the equation, x minus 0 squared plus y minus 12 squared is equal to y. Take square on both sides and then expand the left hand side, y squared minus 24 y plus 144. Then 144. So I know 24y, add 24y on both sides and then minus y squared on both sides. So x squared plus 144. Y is equal to 1 over 24 times x squared plus 144. This is a quadratic equations, and so the shape of the locus is a parabola. Remember, you need to finish example 4 exercise 9 and 10 and then 11. I want to demonstrate the last example. Okay. Read the question first. Example 9.11. A and B are 2 points in the rectangular coordinate plane. There's 2 points. It is given that P move such that PA perpendicular to PB. Can you see this situation? You do not remember the shape of the locus, but according to the given diagram, you know the locus of P must be a circle, because by using the angle in semicircle, converse of angle in semicircle, all the points lying on the circle also satisfy these conditions. So how can we find the equation of locus? You can set up the equation by using the relationship between P and AB. PA perpendicular to PB. So I know the slope of PA times slope of PB must be equal to -1. So y minus 2 over x plus 1 times y minus 2 over x plus 6 is equal to -1. So time x plus 1 and x plus 6 on both sides, you can cancel out all the denominator and then expand it. Move this term to the left hand side, add x plus 1 times x plus 6 on both sides. And then simplify it. This is x squared plus 7x plus 6 plus y squared minus 4y plus 4 is equal to 0. X squared plus y squared plus 7x minus 4y plus 10 is equal to 0. Part B. Verify that the conditions of the point A and point B satisfy the equation obtained in A. Okay, how? Substitute point A. -1, 2 into the equation of locus, the equation of P. Left hand side, -1 all square plus 2 square plus 7 times -1 minus 4 times 2 plus 10. Simplify it, this is equal to 0. It's equal to right hand side. And you can also do the same thing, substitute point B to the equation. But what I want to emphasize is that although A and B satisfy the equation of locus in A, but you need to know P cannot move it to point A to satisfy these conditions. Why? Because if point P is moved to point A, PA is on the same point, so we cannot say PA is perpendicular to PB when P is on the point A. That means I move this point to this one. So if I ask you to describe the locus of point P, how can we describe it? If we use a sentence to describe it, we can say P is a circle. Center at maybe -3.5, and then 2 with radius 2.5 except point A and B, because PA must be perpendicular to PB. If point P is on the point A or on the point B, and this is not okay, P cannot satisfy this condition. So although P is a circle, okay, except point A and point B. Remember, this is very important. But you will ask, Mr. Chair, why? When we substitute into the equation of locus, that's true, okay, satisfy the equation, but you can think about it. Can we substitute the point A to the original relationship? If we substitute it into the original relationship, the first term is equal to 0 over 0. 0 over 0 times something, it's just equal to -1. Okay, may not be true because the denominator cannot be equal to 0. So bear in mind, although point A satisfy the condition, the equation of locus, but point A, P cannot be equal to point A and cannot be equal to point B.